in calculus, pseudo calculus problem. Anyway, we are kind of taking discussion into pseudo calculus problem. Before we move into today, only we will move into another example. But let's finalize the area and circumference to a little bit. Anyway, what we have said that area of a circle, if I divide circle into n number of parts and add all the parts, then we get the area. Okay, what is the ith part area? If this is the circle, okay, if this is the circle and this is the x-axis and this is y-axis, I start from here, and then first section, second section, third section, fourth section, nth section. Means this is the, okay, so this is the first section of the circle, second section of the circle, third section of the circle, and this is the ith section of the circle. This is the circumference of the circle. Okay, this is the circumference means arc of the circle, circumference of the circle. If this is the circumference of the circle, this is delta I, and it makes theta angle with the x-axis. If this is x-axis, then it makes theta angle with the x-axis, and then it is delta theta I, theta and delta theta I. Okay, and this is the arc of the circle. What is the area of this? First section area, second section, ith section. What is the ith section area? In that way, we calculated ith section area is 1 by 2. Consider this is R1 and this is R2 of the ith section. This angle is delta theta I. If that is the case, if that this is R1 and this is R2, this is delta theta I, and this is the arc. This is the arc. If this is the arc and this is R1 and this is R2, okay, in that fashion, the area what we assessed is this. From here, if I take the arc going here, then it will fall like a 90 degree. And in that fashion, this length into this length is at right angle. Okay, if I take multiply this length by this length, it will give the rectangular area, half of it, 1 by 2 R2 into this length. This length is R1 delta theta I. Means ith section, this is what our assumption is. The ith section area is 1 by 2 R2 R1 delta theta I. Now for the full area of the circle is summation I equal to 1 to n. Summation I equal to 1 to n. And then capital A and subscript as I, AI, where AI is 1 by 2 R2 R1 delta theta I. R1 and R2 are, there can be two cases. One is R1 and R2 are constant, like a typical circle where radius never changes. Then R1 and R2 are same and they are constant. I can say now 1 by 2 R square and then summation I equal to 1 to n delta theta I. That is integration d theta. Why d theta? Delta theta I, if I say ith section angle, if this is x-axis and this is radius, then it makes this at delta theta 1. First section of the circle, what is the angle? Delta theta 1, delta theta 2, delta theta 3, delta theta I. Makes sense? Now, if I add all delta theta, delta theta 1, delta theta 2, delta theta 3, delta theta I, and so on, if I add all, or I would say delta theta 1, delta theta 2, delta theta 3, plus delta theta n, all are non-overlapping. No delta theta overlap each other. If I make n equal to infinity also, then net angle would be whatever this angle is, that is 2 pi 360 degree. In that fashion, summation of I equal to 1 to n tends to infinity, delta theta I, where each delta theta I, delta theta 1, delta theta 2, delta theta 3 may not be the same. Okay, they may be different, but adding all them makes the full angle. Limit integration limit of theta equal to 0 to the maximum. If maybe 2 pi for the full circle, 0 to 2 pi, and then I have divided to n part and all parts are non-overlapping to each other. Delta theta I will turn into d theta. This is the repeated summation, molding repeated summation into integration. Integration theta equal to integration theta equal to 0 to 2 pi d theta 1 by 2 r square. Then area will come as pi r square. Okay, I believe it is all right. Now second thing is, if area, ith section area is 1 by 2 r2. This is the first, this is the circle, and I divided circle into n number of parts, moving the radius. Now this is the first part, second part, and this is the ith part. For the ith part, this radius may not be the same. Entering radius and exiting radius may not be the same. Radius may vary with the angle. If it has made theta angle progress from here to here, then radius is something. Then here this is theta plus delta theta I. This radius is at theta plus delta theta I. This means that radius is changing. I'm sorry. If radius is function over theta and both have theta with the x-axis is different, this radius theta with x-axis is theta, whereas this radius with x-axis theta is theta plus delta theta I. In that fashion, if radius is function over theta, then this radius and this radius are different. In that fashion, I call it R1 and I call it R2. The AH part area is R2 into this arc. Arc is not a straight line, but since delta theta is very small, I consider arc as a straight line. So straight line will fall directly upon R2. And a straight line, this arc length into this length by 2 will be the area. This arc length is R1 delta theta I. Too much approximation we are making, but whatever it is. The ith section area is 1 by 2, 1 by 2, 1 by 2 function over theta, 1 by 2 R2 into R1 delta theta I, 1 by 2 R2 into R1 delta theta I. R2 is function over theta and R1 is function over theta. Someone can write it as 1 by 2 function over theta plus delta theta I into function over theta and delta theta I. Okay, considering delta theta I is very small, I can take out theta plus delta theta I. I can say f theta 1 by 2 function over theta into function over theta delta theta I. Too many assumptions are there, but still the ith section area is 1 by 2 function over theta whole square delta theta I. Summation I equal to 1 to n. I believe it is all right. If that is the case, then this is a fit case to convert into integration. That is 1 by 2 integration of theta function over theta whole square d theta. Okay, why it can be like that is someone has to watch it very minutely. Someone has to watch it very minutely. Consider this is x-axis. This is theta axis. This is theta axis. If this is theta axis, very minutely someone has to watch. Consider this up. Consider this is theta axis. If this is theta axis, this is origin, and it is theta is going like this. This is radius axis. This is theta r plane. What are you talking? I am talking about theta r plane. If it is theta r plane, consider this is theta axis. This is theta axis. This is r axis. Theta axis, r axis. Now here, theta, I have theta axis to some point. Consider this point is some point. Call it as a check mark. Okay. Consider this point is alpha. 0 to alpha, check mark. 0 to alpha on theta axis, I divide it into n parts. When n tends to infinity, okay, I divide into n parts. Not necessarily that all parts are of same width. Okay, now I divide 0 to alpha on the theta. Please watch this very carefully. Okay, 0 to alpha, I have two options now. It is 0, what it is? It is 0 to alpha. If it is 0 to alpha, then I can divide into alpha part. Alpha part, 0 to alpha. Alpha consider it is 10. Then I divide into 10 part, 1 part, 2 part, 3 part, 4 part, 5 part, 6 part, 7 part, 8 part, 9 part, 10th part. At the end of 10th part, it is alpha distance. Okay, if it is 1, alpha equal to 1, then 1 part. 10 alpha part, I have divided it. Now, at each location, at in each section, 0 to 1 is the first section, 1 to 2 is second section. Like that, last section is alpha minus 1 to alpha. In each section, consider I have a vertical bar. Makes sense? Each section 0 to 1, I have a vertical bar. Not necessarily it is spanning the full 0 to 1. Somewhere I have a vertical bar. Very thin one line is there. Now I have 1 to, in 1 to 2, I have a vertical bar. In 2 to 3, this is a trillion dollar scenario. If someone understands this, then full statistics, probability, and probably artificial intelligence as a repeated summation is concerned, it is his. Okay, in that fashion, if I do like this, then what will happen? Now I have 10 parts. I have 10 parts. There are 10 bar here. Okay, there are 10 bar here. What is the summation of this? Summation of this, if I say, what is the summation of all the bar? What is the bar? Consider bar is R. Vertical is R, right? I have axis, I have theta axis and I have R axis. Theta axis, R axis. Theta R plane. Each bar is the height that represents R at any particular theta. Okay. Now consider that height is function over theta somehow. So at any place, if I say what is the bar location, what is the bar point? One bar is at 0.5, one bar is at 1.5, one bar is at 1.7, but it will be inside the section I have created. One bar is at 0.5, one bar is at 1.5, one bar is at 2.7, one bar is at 3.3, like that. But in one section there is one bar, only one bar is there. Consider bar height is theta square. If theta is zero point 0.5, then bar is 0.5 whole square, like that. Okay. Now in that way, what is the summation of all the bar? Can I write like I equal to 1 to alpha? Alpha sections are there. I equal to 1 to alpha, and then f theta, where theta is where it is. F theta. Make sense? It is all right. F theta. If theta is 0.5, it will be 0.5 whole square. That is the function. If it is 4.444, then it will be 4.444 whole square. But between 4 and 5, there will be one bar only. How I can convert into integration? Can I convert into integration? What is meaning of converting into integration? First thing, we are calculating repeated addition, repeated summation, that is summation of I equal to 1 to n, and then f theta. Makes sense? This is theta axis, and from 0 to alpha, I have divided into alpha part. One part is of width 1, not necessary. But right now consider it is width 1, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, like that. And last part is alpha minus 1 to alpha. In each section, there is one line, vertical bar. Each section, it may be anywhere in this section. What is addition of all the bars? If vertical bar is a function over theta, the height of the bar is function over theta, that is theta square. That is summation of I equal to 1 to n, function over theta, that's it. How much it will be, whatever, someone has to add it. How can I convert into integration? Certainly, we can convert it to integration. What it is? It is now theta is from 0 to alpha f theta. Theta from 0 to alpha f theta. Okay, okay. Thank you very much. Thank you very much. Now we are into example where we have we are in a mode of area calculation. Area calculation, we have now 1 by 2 summation of I equal to 1 to n, function over theta whole square d theta, and function over theta whole square delta theta I. This is what we have seen the area calculation. Can I convert into integration? That is a question mark. Okay, so for that again I am taking another scenario. Consider that I have a theta axis. I have a theta axis and I have 0 to alpha. And now I divide into n part. From 0 to alpha, I divide into n part, where n tends to infinity. Too high. Alpha is 10, but still n is infinity. So many small sections I have divided into it. Now in each section I have a bar now, and bar is function over theta, that is theta square. Now I am writing the summation of all the bar. I equal to 1 to n, summation I equal to 1 to n, function over theta, function over theta. Okay, function over theta, theta I, function over theta, where theta equal to theta I, theta I. Now I add all the bar, n bars I added. Is it equal to, is it equal, oh, I'm sorry, can I convert into integration now? Summation sign, summation sign I equal to 1 to n, summation sign I equal to 1 to n, and then 1 to n, and then f theta at theta I. Is it same as integration of theta from 0 to alpha f theta d theta? Certainly not. Someone would say, boss, you have divided into infinite part. Do you remember it? Now every part has a vertical. If you add it, it will go to infinite. There will be two too many. But if you integrate it, it will give you the area. If you draw all the bar and make a line over it connecting all the bar, whatever is the area underneath, this is what you are getting with the integration. Okay, that will be far less than if you add all the n tends to infinite bars. Okay, then you said it is same with if it is alpha bar I have created 0 to alpha. If I create alpha number of bars, then integration will work. But if I create n number of bar where n tends to infinity, then it will, so both are not same. Okay, what is not same is alpha summation sign I equal to 1 to n f theta at theta equal to theta I. It is not same as I equal to 1 to alpha f theta at theta equal to theta I, because there are only alpha bars are there. Here innumerous bars are there. In that fashion, then which one is candidate for the integration? Second one is candidate for the integration. Why it is candidate for the integration? Why this is not candidate for the integration? That is the question mark. In my mathematical computation, I have done like this, n different parts, where n tends to infinity, and then I have written this like how I can calculate it into integration. Okay, that is the question mark. Why second one, that is alpha equal to 1 to n f theta at theta I, it can be converted into integration sign theta equal to 0 to alpha f theta d theta, because integration gives the area. If someone have divided into alpha number of part where theta axis is 0 to alpha, if theta axis going from 0 to alpha, okay, and then he dividing into alpha number of part, then what is the integration? Integration is nothing but whatever is the this height into width, area. It gives the area. If I am saying I have integration summation sign I equal to 1 to alpha f function over theta at theta equal to theta I am summing all the alpha bar, alpha number of bar. Each bar has the height and spanned over 1 unit of area. Each bar has a height spanned over 1 unit of area. Indirectly, I can write as summation I equal to 1 to alpha f theta function over theta at theta equal to delta theta equal to theta I into 1. Makes sense? Into 1 I can rewrite as delta theta I, where delta theta, all delta theta I is 1 only. So I can rewrite as summation I equal to 0. Summation I equal to 1 to alpha. If I have written 0 somewhere, said summation I equal to 1 to alpha section, function over theta at theta equal to theta I into delta theta I, where delta theta I is 1. But whatever it is giving a sign of area of each section, height into width, that is 1. Height into width, that is 1. Here I am saying the width is delta theta I, whatever it is. We are summing the area of each section's area. That will give the full area, more or less integration only. Okay, then it is now integration alpha equal to 0, because we start from 0. Alpha equal to 0, not 1. Alpha equal to 0. I'm sorry, integration theta equal to 0 to alpha f theta d theta. Delta theta I become d theta, and function over theta become function over theta. Okay, thank you very much. But what about if I divide into n section? This is more finer, right? Rather than course 1, 1, 1, 1, 1. Certainly, you can do so. But you have to change your expression. If that expression is summation of I equal to n, I equal to 1 to n, summation sign, sigma sign, I probably, summation sign I equal to 1 to n, function over theta at theta equal to theta I. This is your expression, right? Okay, multiply it by delta theta I. Delta theta I. What is delta theta I? If I have divided into n parts, if theta axis is 0 to n, 0 to alpha, I have divided into n different parts. Every part has a width, that is delta theta I. Means ith part has a width as delta theta I. Okay, then we have delta theta 1, delta theta 2, delta theta 3, delta theta I, and then delta theta n. N number of parts I have divided. Is it all part has the same width? Not required. All part can have different width. But if I add all the widths, delta theta 1 plus delta theta 2 plus delta theta 3 plus delta theta 4 plus delta theta n, it should become alpha. That is the prerequisite. Yes. It is not overlapping, but all the section, n number of section I have divided, all are not same. No problem. Okay, if your expression is summation sign I equal to 1 to n, function over theta at theta equal to theta I into delta theta I. If this is the expression, then you can convert into integration theta equal to 0 to alpha, 0 to alpha, not n, alpha f theta d theta. Okay, first tell me that how it is possible. When I multiply by delta theta I, that is the width of each section. If there are n section on the theta axis 0 to alpha, if there are n section, then I have divided n section, then width of ith section is delta theta I. Because when you multiply height with the width, you are giving the area. Now, indirectly, all the n section, you are calculating the area. Okay, then you add it, you get the full area. That is nothing but integration only. Okay, no. I don't want delta theta I. My expression is I equal to 1 to n function over theta at theta equal to theta I. That's it. There is no multiplication of delta theta I. Then you cannot convert into it. This is what people generally, they come to a fake calculus in the book. Okay, now I have summation, then I can convert into integration. Not possible. If you make into integration, there will be limit, and limit is one point to another point. If your number of section we have divided, it is same as the limit. If limit is 0 to alpha, and then you have divided into alpha section only, then you can go with integration. But your limit integration is 0 to alpha, but you have divided into n part, and that is not equal to alpha. Then summation I equal to 1 to alpha, 1 to n f theta at theta I. This will not get converted into integration. Will get converted into integration if the summation of I equal to 1 to alpha is there. Then f theta I will get converted into integration, because hiddenly delta theta I is coming into the picture with width is 1. Anyway, my main net idea is whatever expression you are writing, each addition in the summation, each addition will lead to the calculation of area of one subsection, and if you add all, then it will become a full area. Anyway, in calculation of the area of a circle, we have I equal to 1 to n. We have divided the area of a circle into n parts. Summation I equal to 1 to n, I equal to 1 to n, and then we have 1 by 2 function over theta whole square. Consider this as vertical. Function over theta whole square, this is the vertical. And then delta theta I means vertical and multiplied by the delta theta. Delta theta means you are now you are dividing your integral area. Integral means the area. Theta axis, and this is the function over theta. And then if you draw a curve will be there. Integration will calculate the area. That's it. Now 1 bar into delta theta I, 1 bar into delta theta I, 1 bar into delta theta I, more or less you are calculating the full area only. So this is a good candidate. This explanation is not there in any of the book. Anyone can try how we convert the main summation into the integration. Now consider what it will be. Now integration sign and angle, how it spans. If r is function over theta, then angle from theta equal to 0 to wherever it goes, and then 1 by 2 function over theta whole square d theta. Someone can calculate the area of the circle. Anyway, we will proceed on this. So we had calculated earlier area of a circle is dp by d theta r. dp, where p is a point on a circle, that is x comma y. dp by d theta r mod magnitude d theta dr, or dp by d theta cross product dp by dr magnitude d theta dr. When I have done this much, let's take opportunity to introduce another question. The new question here is that I have a stick of length 1. Only 1 is the length. Consider 1 meter is the length. Now I cut this stick into two parts. Where from you are cutting? I am cutting this stick at any part. I am cutting this stick from the anywhere. I can cut here, 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 here. But I retain the longest part. Consider I have now n number of sticks. I have kept n number of 1 meter stick. I take one stick, I cut it, and the longer part I throw in one direction. Then I take out another stick, longer part I take and throw out in another direction. I take out one stick, I cut it, longer part I take and throw in one direction. Now n stick, the longer cut portion of the n number of stick I collect. Then I measure the length of this stick. Then what is the average length of the stick? That is the question mark. Makes sense? If I take a stick, then I can cut it into two parts, where cut can be before the half. This is the half mark of the stick. Half mark means it is 0.5 meter. I can cut before 0.5 meter. I can cut after 0.5 meter. Okay. If I cut before 0.5 meter, then this is the portion that I keep it. If I cut after the 0.5 meter, then this is the portion I keep it. Now all the n, the longest part of the cut, if I just gather, if I accumulate, if I assemble, and then I measure all the length, what is the average length of it? That is the question now. Okay, now consider that this is 1 meter length. Consider I divide into n part. I divide into n part. If I divide into n part, then what is the probability that I'll cut in a particular section? If this is divided into n part, then this is the first part, second part, third part, ith part, then, and this is the n minus 1 to nth part. This is the nth part, first part, second part, nth part. This is the ith part. What is the probability that I cut in the ith part, a particular ith part, any part? Probability is same. I can cut anywhere. If I cut anywhere and there are n sections, what is probability I cut in a particular section? The probability is 1 by n. Makes sense? If I have a die, okay, if I roll down, I believe it is called die only. I have never played these kind of games. Okay, so I have a kind of die, or I don't know what it is called. So that where you write a kind of 1, 2, 3, 4, 5, 6. If you roll down, anything would come. What is the probability that it will be 3, 1 by 6? It will be whatever it is. Okay, now if I toss a coin, what is probability? It will be head, 1 by 2. Similarly, if I divide into n part, what is the probability I'll cut in a particular part? 1 by n. Okay, now the probability that I'll cut in any section is 1 by n. Okay, if it is 1 by n, Then what is what? Okay, leave it. Consider that there are students in the class. There are students in the class, and then I saw their marks in the class. Consider there are n students in the class. Consider there are consider there are 10 students in the class. 10 students in the class. When I see their marks, then four students they have secured 50 marks. Four students they have secured 50 marks. Three students they have secured 60 marks. And I'm sorry, four students, three students. One student has secured 70 marks. 50 students have secured, four students have secured 50 marks. Okay, three students have secured 60 marks. One student has secured 70 marks. Four, three, 7 and 8. Two students have secured 40 marks, but all are pass, consider. Or if pass mark is at 40 marks. Okay, now if I divide this in 10 sections, consider I divide into 10 sections. Then first section is people who get mark from 0 to 10. Another is 10 to 20, 30 to 40, 20 to 30, 30 to 40, 40 to 50, like that. In 30 to 40, I have one student, I have two students. 40 to 50, I have four students. 50 to 60, I have two students. 60 to 70, I have one student. Now, question is, what is the average mark? But if someone wants me the distribution graph, then I can give this distribution graph to him. There is a graph where axis is marks 0 to 100, 10, 10 to 100, 10 to 10, I'm sorry, 0 to 10, 10 to 20, 20 to 30, 30 to 40, like that. Now in 30 to 40 section, I have two students. 40 to 50, four students. 50 to 60, three students. And then 60 to 70, one student. What is the average mark? Someone will say, what is this bar chart and this? Give me all the 10 students mark. Okay, I'm giving you. 40, 40, 40, or 40, 40, I'm sorry, 40, 40, 40 plus 40, 50 plus 50 plus 50 plus 50, 4, okay, 60 plus 60 plus 60, okay, 70. Add it and divide by 10. That is the average mark. No, 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 no. You show me in this fashion. What fashion? In the graphical fashion. Okay, you want in graphical fashion. If it is graphical fashion, then consider this is one axis and this is x axis and this is y axis. X axis is the marks and y axis is the density, how much it is. So at the marks 40 to 50, we have density as 4. 30 to 40, 2. 50 to 63, 60 to 71. Now someone would say, what is density at 30 to 40? 2. Multiply with the distance from the origin. That is, consider it is 40. 40. Or if I take middle part, then 35. So from the beginning, take the portion. It is distance is 35. And how many are there? Consider 40 for simplicity. 40. And how many are there? 2. Then 40 into 2. 50. How many are there? 4. 50 into 4. And then 60. How many is there? 3. 60 into 3. 70 into 1. Add it and divide by the number. Make sense? So this is called x-axis, that is the number. That is the number. And this is y-axis called density. How many people are there in one number? So how much is the net amount we are getting? Net amount is x-axis and the height plus x-axis and the height plus x-axis and the height plus, like that. Is it not like x into function over x? If height is function over x, then it is x into function over x. Typically it is called expectation. These explanation is still not there in any of the book. Y expectation is summation of x fx. Anyway, this is how it is. So now we will go back to the kind of, now we have everywhere. If I cut it, then everywhere probability. Now talk in probability. If I talk in probability, then probability. What is the net result? Net result is 2 into 40 plus, in the mark section, 2 into 40 plus 4 into 50 plus 3 into 60 plus 70 by 10. Okay, leave it. What is the probability that someone would get 4? People are 4 in the 50 section. There are 10%. How much how much percentage it is getting 50 marks? 4 by 10. I can draw in a probability density function also. If this is x-axis, then at 40, we have 2 by 10. At 50, 4 by 10. At 60, 3 by 10. And 70, 1 by 10. What is 10? 10 is the number of people. Then what is the average? Now average is, we do not divide by n now. X and probability density. Earlier it was density, now it is probability density. Now it is x into fx. What is it? Is 40 into 2 by 10 plus 50 into 4 by 10 plus 60 into 2 by 10, 3 by 10 plus 70 into 1 by 10. Just you do it, you get the average mark. Similarly, if I divide it into this line into n number of parts, and everywhere probability is 1 by n, 1 by n, then how much is the average length now? Now let's see this. See it minutely. Now I cut, this is the middle. I cut before the middle. Okay, and that is the ith section I am cutting. If I am cutting the ith section, what is the distance here? I into 1 by n. Make sense? Each section has width as 1 by n. Ith section I by n. I by n into the height. That is what, this is what we learned. X into fx. X is I by n. If I cut before this, then length will be this one. It will not be I by n. Let's cut after 50. If I cut after the 50, then what is this length? Length, then it will be I by n. I by n into the height, that is 1 by n. I by n into 1 by n. This is the net addition. This is the average mean. Summation I by n into 1 by n. But condition is that I is greater than n by 2. If n by 2 is the half number, then I is greater than n by 2. Then it is I by n into 1 by n. Width into height. That is the total count. Okay, total count divided by the total, how much they get, and by the way we said. If I cut before it, then this section I have to take. Then it will be, this section is n. This full length is 1. 1 minus I by n. I by n is the net length. 1 minus I by n, that is this length, into 1 by n. Okay, now I can say that the average length of the stick is I by n into 1 by n if the ith, where we are cutting, ith section is more than n by 2. Okay, one idea, plus I have to add it because they are mutually exclusive, plus 1 minus I by n if I cut it before it. Okay, then 1, because I have to take the longer section, 1 minus I by n into 1 by n. If I do this summation where I equal to 1 to n, this will give me the average length of the stick. Why you are kidding like this? Is it really possible? Certainly. Someone can try. We will do it in the next section. So this is where we will see how miraculously the integral calculus enters into. This is another example we have started. So this is the summation we have got. Summation I equal to 1 to n, where n number of parts. This example probably available on the internet or anyway I can think of, but this explanation is certainly not available in any of the book. I equal to 1 to n, I by n into 1 by n plus bracket 1 minus 1 I by n, 1 by n. If someone calculates it, it will really give the average length of the stick. We will see it with this repeated summation. Then we will see with the integration also. Can it be converted into integration in what scenario? Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.